let's see the properties of determinants. The first one is reflection property. Reflection property means the determinant remains unaltered, means the determinant will not change if its rows are changed into the column. In the transpose of A, all the rows becomes the column of the matrix A. Okay, so if you're finding the determinant of A dash, that will be same of the determinant of A. Okay. So just telling you one example also. Suppose you have a matrix, this one, and you're finding the determinant of this. So what will be the determinant of this? The determinant of this, suppose this is A, so the determinant of A will come out -6. Okay, now if I'll take A dash or transpose of A, in the transpose of A it will become like this. Now if you find out the determinant, so what will be the determinant? -6. So you've seen, if you'll transpose a matrix, then the determinant of the same matrix A and its transpose will be same. So this is the first property. Let's see the next property, that is all zero property. If all the elements of a row or a column are 0, then the determinant is 0. It's very simple. If any row of any matrix A is 0, then the determinant of A will be 0. See? And the same case, if the B is another matrix and the column is 0, then what will be the determinant of B? The determinant of B will be again 0. Okay. So if all the elements of a row are 0 or column are 0, then the determinant is also 0. Next one is proportionality or repetition property. Repetition property means if all the elements of a row or a column are proportional or identical same to elements of some other row, then the determinant is 0. Okay, let's see the example of it. Suppose you have A, one of the row is 2, 4, 6, and another row is 1, 2, 3, and the other row is 1, 0, 1, 1. Now you can see this row and this is twice of the C2. Okay, so in this case, if we find out the determinant will come out to be 0. You can find it also. Okay, let's make it 0. So determinant will be along this row, we will find out, so it will be 4 minus 4, it will come out to be 0. Okay, the same way, if in rows also, suppose B is another matrix and B, determinant of B you're finding, and here one of the row is same 2, 6, 8, and here it is multiple of this. So here if we find out the determinant of this also, then it will also come, see 8 minus 8 into 1, so it will be 0. So I hope this is clear. If the elements of a row are proportional or identical to the same other row, then it will be, determinant will be 0. Let's see the another, that is the switching property. If we interchange any two rows or columns, then the determinant will change its sign, means that the determinant will become negative. Okay, let's see it with the example. Suppose we have A and A is 1, 2, 3, 4. Okay, now what will be the determinant of A here? It will be 4 minus 6 equals to -2. Okay, now I am interchanging the row 1 with R2. Then let's see what will happen. So it will become 3, 4, 1, 2. Now let's see the determinant. Suppose it be, so determinant of this will be 6 minus 4. So it became 2. So here you have seen, if we interchange the row, same way if we interchange the column, the determinant will be negative of previous. So you can also say, suppose we are changing the I row with J row, then the determinant of B, means the new one, will be negative of the determinant of A. So I hope this one is clear. Now look at the next one, that is the scalar multiple property. Scalar multiple property means if in a determinant you are multiplying any row with any constant or non-zero number, then the determinant will also get multiplied by the same constant. Okay, so here I have taken this one. So suppose the determinant of A, what will be the determinant of A here? Along with the third column, if we'll find out, so it will be 3 minus 2. Okay, so it will be 1. 3 minus 2, it will be 1. Now here I am changing the first row. I am writing this first row as twice of the first row. So here the first row will become 2, 2, 0, and here it will be 2, 3, 2, 4, 0, 1. Okay. Now we will find out the determinant of this one. So the determinant will be 6 minus 4. So it will be 2. Okay. So here you've seen I have multiplied the first row in the determinant with 2. So the new determinant also gets multiplied with the same number. You can also write this thing as if Ri, you are replacing this Ri with Cri, means you are multiplying the row I with a constant C, then the determinant will change, like A and B it will become. So then you can say that the determinant of B will be how much? C times of determinant of A. I hope this one is clear. And the same thing you can do with the column also. So suppose you are replacing any column I with Ci. See, here I am taking the D. Okay, D, Ci. So then what will happen? Here, your determinant of B in this case will become B times of determinant of A. So I hope this one is clear. The next is sum property. Sum property means if any row or a column is written as the sum of some numbers, then you can write the determinant as, you can take the first all together and the other two columns as it is, and the second one, which is as a sum, you can write in the another column. So the determinant will be same. So let's see example. Suppose you have one row that can be written as 1 plus 2, 2 plus 3 and 3 plus 4, and the other here it is 3, 0 minus 1, 0, 1, 1. Now if you find out the determinant of this, so what will be the determinant? Here if you'll see, so in this the determinant of this will come minus 12. Now I have taken these individually. I have taken 1, 2, 3 as the first row, and these two rows same. And here in the second I have taken 2, 3, 2, 3, 4, and the other two rows same. So here after solving this, you will get determinant of this will be minus 5, and after solving this, the determinant will come out minus 7. Now you can see this minus 7 and minus 5 sum up to minus 12. So I hope this property also clear. Now let's see the next property. In the next property, suppose you have a row, okay, and you can write this row as Ri plus K into some other row. Okay. Now if you are doing this kind of operation, then the determinant will not. See, here I have taken a matrix. First row is 1, 2, 3, 1, 1, 0 and 2, 3, 0, and I am doing the operation here. R1 I am writing as R1 plus 2R2. So after doing this, you will get this matrix. Okay. Now we will find out the determinant of this first one. So it will be 1 into 0. This one will be 1 into 0. Then minus 2 into this one will be also 0. And then you will get plus 3 into 3 minus 2. Okay, so overall it will be 3. So here the determinant of this came 3. Now we will see the determinant of the other one. So here we find out the determinant of this one. Here also the first you will get 3 into 0 I think, and the next one will be 4 into 0, and the last one will be 3 into this one. Here it will be 3 minus 2, so same. So here it will be also 3. So now you see in both the cases you got 3. So after doing the changes also, if you can write any row as that row plus any constant into sum of any constant into the other row, and same thing you can do in the column also. Now after this you have the last one, triangle property. Triangle property means you can see in the triangle, the diagonal elements, above the diagonal elements are there, but below there are only 0. So in these kind of, the determinant will be product of the diagonal, that is A1, B2 and C3. Okay, same thing, if you have a diagonal, below the diagonal the elements are there, but above the diagonal all the elements are 0. So in that case the determinant will be the product of the diagonal. So these properties you can use directly